Hi, everybody. It's Professor Mitchell. We're continuing with our review from Chapter P. And again, the point of this is to warm up for Section 5.1, which is verifying trigonometric identities, and that uses a lot of algebra. So we want to hone up on our algebra. So when I go to the objectives for this section, you see that I have a few things crossed out. These things that I have crossed out are not going really to come up in section 5.1. Now, sometimes what I say to you is, okay, I'm not going to cover these things in the trig class. We'll do them when we get to pre-calc. Actually, in pre-calc, we don't do anything from chapter P, I guess, unless the instructor really feels like they need to. So factoring is a thing that comes up in calculus, but I would say 99% of it is the stuff that we're going to be reviewing. Okay. Oh, except for factoring algebraic expressions containing fractional exponents. That's a thing that would be nice to go over at some point. Maybe that I will do in the pre-calc class. All right, so factoring a polynomial means finding an equivalent expression that is a product. So you're taking a polynomial and writing it as the product, as multiplication, of two smaller polynomials. So this is exactly the reverse of what we were doing in section P4. In section P4, we were multiplying polynomials. That was when we went over FOIL, for example. So factoring, we're undoing that, okay? All right, so let's look at some of the different factoring tricks, and hopefully you remember most of these. Number one thing to remember when you're factoring is always look for a greatest common factor first, all right? So greatest common factor is an expression of the highest degree that divides each term of the polynomial, and I have a couple of examples of that. So if they ask you to factor 10x cubed minus 4x squared, let's think about this for a second. The biggest number that divides into 10 and 4 is 2, right? So part of the greatest common factor is going to be 2. And then I look at my x terms, and I see that I have x to the third, I have x to the second. So the highest power that divides into both of those is x to the second. So in the case when you have the same variable in every single term, that variable to the smallest power is going to be part of your GCF. So the greatest common factor for 10x cubed minus 4x squared is 2x squared, right? So once you decide that your greatest common factor is 2x squared, it's almost like you divide each term by 2x squared. This is a thing that I sometimes call my thought bubble. Inside my thought bubble, I'm thinking to myself, what happens to this thing when I divide each term by 2x squared? Well, in the first term, I would be left with a 5x. And in the second term, I'd be left with a 2. Okay. So since each term is divisible by 2x squared, I can sort of undo the distributive property and write that 2x squared out front. And the other factor is 5x minus 2. Okay. 2x squared times 5x, you see that over here. 2x squared times minus 2, you see that right here, okay? So that's factoring out the greatest common factor, okay? So we'll look at one more example of factoring out the greatest common factor. This will be a warm-up for factoring by grouping. So the next example is factor 2x times x minus 7 plus 3 times x minus 7. So especially when I do something like this in an intermediate algebra class, people get a little confused, all right, because of this x minus 7. And what I always say about this is imagine for a second forget about x minus 7. Pretend that this is a 2xy plus 3y. All right, now all of a sudden it looks much simpler. If it said that, the GCF would be y. And after I factored out the y, I would just be left with 2x plus 3, right? Well, it works exactly the same way. So playing the role of y right now is x minus 7. So instead of factoring out a y, I'm going to factor out an x minus 7. Okay, so here is the x minus 7 times 2x. You see that over here. X minus 7 times 3. You see that over here. All right, so the next factoring trick is factoring by grouping, and that's what they were warming us up for in that last example. Factoring by grouping is usually used on polynomials with 4 terms, okay, almost all the time. So this is when, and again, the first thing you should always look for is a greatest common factor. See if there's anything that all the terms have in common that you can take out right at the beginning. But even if you can't, the next trick is, especially if you notice that your polynomial has 4 terms, try to factor it by grouping. So in other words, maybe all 4 terms don't have something in common, but maybe the first 2 do. And maybe the second 2 do. Okay? That's called factoring by grouping. So let's look at an example of that. I might just have one example here, but then I'll have another one later. Okay. X cubed minus 5x, or I'm sorry, x cubed plus 5x squared minus 2x minus 10. Okay. So the first thing I look for is there anything that all 4 terms have in common? And the answer is no, right? I mean, the x cubed and the 10 don't even have anything in common. So how could all 4 have something in common? Okay. So GCF is not going to help me. The greatest common factor is 1. So the next thing I'm going to try is grouping. So I'm going to look at these 2 terms, and I'm going to look at these 2 terms. And I'm going to ask, is there anything I can factor out of just these 2 terms right here? And the answer is yes, right? I can factor out an x squared. Okay. So this is basically showing you how it works. So the first thing they did was they grouped the terms. I used a bracket for that. They're using parentheses. And then they're noticing that out of these first 2 terms, you can pull out x squared, because again, that is the smallest power of x that's in every single term. After you pull out the x squared, you are left with x plus 5, right? Remember that thought bubble. If you divide this term by x squared, you're left with x. If you divide this term by x squared, you're left with 5, right? So you pull x squared out of those first 2 terms, and that leaves you x squared times x plus 5. Now I'm going to look at these last 2 terms. If I pull a negative 2 out of the last 2 terms, I am going to be left with x plus 5. Now notice, because this is really important, that these 2 things here are exactly the same. Factoring by grouping only works when you can make those 2 exactly the same, because now this is just like the last example, isn't it? This was like the 2x times x minus 7, and then the plus 3 times x minus 7, I think it was. So now I do have a common factor. My common factor is x plus 5. So I'm going to park that x plus 5 out front, and my other factor is x squared minus 2. Okay, so that takes us to factoring trinomials. Now this, I guess, ivory colored box here, you're going to hear me explain all of this in the next 2 examples. So it's, I think, easier to listen to the explanation than it is to try to process this ivory box. All right. So let's look at the examples. When your leading coefficient, when the leading coefficient of your trinomial is 1, and how do I know it's 1? Because I see the x squared here with the invisible 1 on it, right? That is the easiest kind of trinomial you can hope for. So the way that works is I say, okay, this thing must factor into x something something, x something something. I did not make this slide. I would have put more space in these sets of brackets here, but you'll see it in a second. And I just noticed this is a completely different problem. Okay, so you know how we're going to fix that? Let me see. How are we going to fix it? I'm trying to think if this problem is even doable. Hold on, I'm going to pause the recording. Okay, so I have fixed the typo. Sorry about that. We are in fact doing this problem, x squared plus 13x plus 40. All right, so the first thing I do is I write, well really the first thing I do, I think I'll add this in up here, is there a greatest common factor? And you're going to see me do an example later where there is a greatest common factor. Okay, I don't do really well with the marker type of pen, do I? Okay, so nothing helpful, just 1. Okay. All right, so I start factoring x something something, x something something. Now think about what this something something has to look like, whatever is in this blank. If you think about how FOIL works, those two numbers that are in those blanks are going to have to add up to 13 and are going to have to multiply to 40. Which is what you see here. So find two last terms whose product is 40. Okay, the L in FOIL will take care of that part. So the choices are either 1 and 40, 2 and 20, 4 and 10, or 5 and 8. So now you look over those pairs of numbers and pick the one that adds up to 13, and you can see which one that is, right? So the numbers that add up to 13 are 5 and 8. Okay. So now instead of saying x something something, x something something, I can say that this factors as x plus 5, x plus 8. And I always encourage people to check those. The great thing about factoring, it's not always easy to do, but it is always easy to check. So this one you would check using FOIL, all right? So I take x plus 5 times x plus 8, just like we were doing in the last section. X times x is x squared. Outer would be x times 8, which is 8x. Inner would be 5 times x, which is 5x. And last would be 5 times 8, which is 40. And when you combine your like terms in the middle, you get x squared plus 13x plus 40. All right, so the next example of factoring a trinomial is this one here. So notice that the x squared has a 3 in front of it, which means that it's not going to be quite as simple as what happened in the last example. Okay. So there are two different ways to do these that I like, depending on what the trinomial looks like. So for this particular trinomial, I would use trial and error, which by the way is the only way that I learned. All right. So here's how trial and error works. So first look for your greatest common factor, and I see that it's 1 again. Okay. So the greatest common factor is not going to help me. Okay, now 3 happens to be a prime number, which is kind of handy. So really the only reasonable way to break up the 3x squared is 3x and x. So I'm going to write 3x squared minus 2x minus 5 equals 3x something something x something something. So now I have to decide what to put in these blanks. Okay. The good news is that those two numbers will add up to, I'm sorry, will multiply to 5. Okay, so that part is just like the last example. The bad news is those two numbers will not add up to -2. That part is out the window because of this 3 sitting in front. So this is a little bit more work. Okay. So now I am going to think about the 5. Fortunately, 5 is also a prime number. And by the way, this is why I'm using trial and error. When the first number and the last number are both prime, it means that there are very few things that could actually work. Okay. All right, so the only possibilities for how this is going to work, if it's going to work at all, and that's even another possibility, is maybe it's not factorable. All right, there is such a thing as a prime polynomial. Okay. So it has to be one of these. It has to be either 3x with a 5, x with a 1, or 3x with a 1, x with a 5. And the signs, I worry about those very last thing. Okay. So the way that I'm going to decide which one of these is I'm just going to try things until I find the one that works. So the reason I like trial and error for this kind of problem is because there aren't a whole lot of things to try. So I've already taken care of the F in FOIL. I've already taken care of the L in FOIL. Now I have to take care of the outer and the inner. Okay. So the outer for this one, and again, I have not figured out the sign yet, would be some kind of 3x. And the inner would be some kind of 5x. And when I combine those, I need it to come out to be -2x. And I see that that will work as long as the 5x is a -5x and the 3x is a plus 3x. If the 5x is a -5x, then that means that the minus has to be here. And if the 3x is a plus 3x, that means the plus has to be here. So this thing has to factor as 3x minus 5 times x plus 1. All right, so the last example I have of factoring a trinomial is this thing. First of all, I wouldn't even think about using trial and error on this because there are too many possibilities for the 6x squared. That could have come from either 6x and x, or it could have come from 3x and 2x. Okay, so I would have two different sets of things to try there, and then the 12 would just be kind of a nightmare. It could be 1 and 12, it could be 2 and 6, 3 and 4, and then on top of that, also 4 and 3, 6 and 2, 12 and 1. Okay, so forget about trial and error. I don't want to use trial and error. So the way that they, and again, I did not learn this way. The only way that I learned was trial and error. I had to teach this way to myself when they started teaching it in high school, I guess. It's called the AC method. So the way that that works is you find two numbers that add up to -17 and multiply not to 12, but to 72. And where did they get the 72? They got it from 6 times 12. That's why it's called the AC method, because this thing, we often think of it as ax squared plus bx plus c. So that number is called A, that number is called C. So I need two numbers that add up to -17 multiplied to 72. And by the way, it's sort of traditional for some reason that when they do this kind of problem, they make this little diagram where at the bottom they write plus -17, and then on top they write times 72. I don't know how much that really helps, okay, but I see a lot of people do it. Okay, so you think about that, and you think about it, and you think about it, and eventually you come up with -8, -9. Those are the two numbers that add up to -17 and multiply to +72. So sometimes they will write those numbers over here. Okay. Again, I don't know how much this part really helps. Okay, now what you do with that -8 and that -9 is you make this into a factor by grouping problem. You take that -17x and you break it into -8x, -9x. You're going to see this all typed out, but might be helpful. This is the way that I would normally do it, like on the whiteboard. Okay. Break that into -8x, -9x, and what happens is you get this factor by grouping problem. So now if you think back to factor by grouping, you look at the first two terms. What can you pull out of the first two terms? You can pull out 2x, right? Then you look at the second or the last two terms. What can you pull out of those? You can pull out -3. Okay. I would say almost 100 times out of 100. I almost said 99 times out of 100. If there is a minus sign in this exact spot right here, you're going to want to factor out a negative number. So what it's going to look like then is like this. So I factor a 2x out of the first two terms. I end up with 2x times 3x minus 4. I pull a -3 out of -9x plus 12. I end up with -3 times 3x plus 4. My common factor is 3x minus 4. My common factor is 3x minus 4. I pull that out. My other factor is 2x minus 3. Okay, so the last factoring trick that we're going to review for purposes of Chapter 5 is difference of two squares. And this is something that we've used before. We used this when we went over rationalizing the denominator when there's more than one term. For example, if you have a 1 over the square root of 6 plus 2, we went over how you multiply the top and the bottom of that by the conjugate, by square root of 6 minus 2, because then it makes it fit this pattern. And it just so happens when you multiply an a plus b times an a minus b, you get an a squared minus b squared. When you FOIL it, the outer and the inner terms drop out, right? Because the outer is minus ab, the inner is plus ab. Okay. So this is a factoring trick that comes up pretty frequently. So let's review how that works. In this example, so I have 36x squared minus 25. Again, I want to emphasize over and over, look for a greatest common factor first. In this case, there is nothing helpful. The greatest common factor is 1. All right, so then I'm going to notice that these two terms are both perfect squares. This is the square of 6x, and the other term is the square of 5, right? So that means in that pattern that I was just showing you, a squared minus b squared equals a plus b times a minus b. Playing the role of a is 6x, playing the role of b is 5. So this thing is going to factor into 6x plus 5, 6x minus 5. And I also want to mention again, factoring problems are very, very easy to check. They're not always easy to do, but they are always easy to check. So if you're ever not sure that you have factored something correctly, go ahead and check it by using FOIL or whatever kind of polynomial multiplication makes sense. All right, so this example goes under the category of use a general factoring strategy, which just means that there might be more than one factoring trick that comes up in a given problem. So the way I would do this one is, again, start by looking for greatest common factor, and this time I think there is something worth pulling out, right? I can think of a number that divides into 3, 30, and 75, right? You can take a 3 out of all three of those numbers. And because all three terms have x's in them, you have x to the third, x squared, and x. You can take out an x. So the very first thing I'm going to do with this is factor out a 3x. So after I factor out the 3x, I am left with 3x times x squared minus 10x plus 25. Again, when you're trying to figure out, what that other factor is, just imagine that you're dividing each term by 3x. So that's how you get the x squared. That's how you get the minus 10x. And this is how you get the 25, right? Okay. So now, this is a trinomial with leading coefficient 1. So those are the ones that are really simple. Just think of two numbers that add up to -10 and multiply to 25. And you don't have to think about it very long before you figure out that those two numbers are -5 and -5, right? Okay, so, all right, I did not talk about perfect square trinomials because it's really not that important for what we're going to be doing in chapter 5. It does fit this pattern, okay? Or you can just do it the way I just said, which is that the numbers that add up to -10 and multiply to 25 are -5 and -5. So you can break this thing into x minus 5, x minus 5. Okay. So when you do that, you get this thing, all right? So they wrote it as x minus 5 squared. Just be aware that that is exactly the same thing as x minus 5 times x minus 5. So we'll write that in there. And I think that will do it for what we need from section P5.